So good morning everyone. So we are back and today we are going to do the important questions. Okay, important previous year questions of photoelectric effect, de Broglie's wavelength, all about this chapter, that is dual nature of matter and radiation. Okay, so first of all, I have written 6 questions on the blackboard. Okay, try to solve it by yourself. Okay, these are all 1 marks question as I have written this. Okay, so one by one we will do 1 marks question, 2 marks question, 3 marks and 5 marks along with some MCQs from this chapter. So without wasting any time, okay? Without wasting any time, let's get into it, okay? Uh, First of all, we have name the phenomena. Question number 1, CBC 2017. Name the phenomenon which shows quantum nature of light. Okay. So here what it says. Name the phenomenon which shows quantum nature of light. So it's quite easy. You just be confused with this term, that is what is quantum nature. So here what quantum means, particle. Okay, the meaning of quantum here is particle. So in fact you have to say which phenomenon shows the particle nature. 먼저 가장 particle nature 나는 수비기 solution. particle nature 때문에 가래 photoelectric effect. Okay, nature 때문에 experiment 뭐고 연이 수업이요. But in your syllabus we only have photoelectric effect. Okay, photoelectric effect. So don't worry, in CBSE exams, 계시 안기치기 좋아이나 그냥 이 센텐스나 디나리기데 야면은 주주 많아나 그냥 이 메인 one word 매치 슈페션을 디지 디 렌디가 photoelectric effect. So 디지 quotation 디기데 you will get 1 marks. Okay, this is so answer correct photoelectric effect. Now question number 2. Monochromatic light of frequency 6.0. So that means it's 6, okay, 6 to 90 degree. 6 into 10 to the power minus 10 to the power 14 hertz produced by a laser. Okay, this is produced by a laser. What is the energy of a photon and its wavelength? Okay, so here you have to find energy and the wavelength of photon. So here, energy of photon can be written as h nu. Is it? So energy is new so energy E is equal to h means Planck's constant. Okay, this equation is called Planck's equation. Okay, this equation is called Planck's equation. Now E is equal to h nu. So E is equal to 6.625 into 10 to the power minus 34 into nu is what? 6 into 10 to the power 14. 상하 SI는 돼. Okay, 6.6 into 10 to the minus 14. So energy is equal to 6 6 are 36. So when you solve this, you will get about 39.83. Okay, 39.83 into 10 to the power 10 to the power minus 34. So 10 into 10 지유나 power subtract so 14 minus 34. So minus 20. So your answer would be E is equal to 39.83 into 10 to the power minus, or something like 40 into 10 to the power minus 20. You can write this as 4 into 10 to the power minus 19 joules as well. Okay, and it's 19. So, these are mathematical terms, but you just need to know the physics of this particular question. That is the formula. Okay. Now what we have to find? We have to find the wavelength. The wavelength here E is equal to hc by lambda formula here. Okay. I just want to give you this as a homework. Okay, the wavelength can be set up. Okay, and don't forget to write this in the comment box, whatever answer you are getting. Lambda here, energy that is 4 into 10 to the power minus 19 joules. Hd how you see, and speed of light is 3 into 10 to the power 8 meter per second. What? Lambda you can find lambda easy. Next question, two particles have equal momenta. What is the ratio of their de Broglie wavelength? Okay, the de Broglie wavelength ki ratio khare if their momenta is same. Tamo de Broglie wavelength khare h upon b there. So so क्या लिखा है momentum P1 is equal to P2 further equal to P, that is given. Okay, given that P1 is equal to P2 is equal to P. So lambda 1 upon lambda 2 is equal to H upon P1 into P2 upon H1 H sorry H cancel P1 P2 triple cancel answer is 1. Okay, ratio is easy, that is 1. Okay, CBSE 2018 this sample over there. Next question. Show graphically the variation of de Broglie wavelength and the potential. Okay, de Broglie wavelength lambda V की variation graph करना. De Broglie wavelength in terms of potential is equal to h upon under root 2m qv. Formula is lambda is equal to h upon under root 2m qv. So therefore lambda is inversely proportional to 1 by root 4. Lambda is inversely proportional to 1 by root v. So any in graph 100 again. Lambda in this is your origin. dB in graph 100 again. If linearly proportional inversely proportional root में straight line but since it's a root, you will make a graph like this. Okay, so the end logic like this. Okay, so this is the relationship. Similarly, the lambda similarly lambda kinetic energy की से elasticity. So lambda is inversely proportional to kinetic energy. Formula that is lambda is equal to h upon under root 2mv. Okay, in this case as well, you will get a graph like this. Okay, the case में यहाँ graph दी रही है. Fine. Okay, now question number 5. CBSE 2012 question day. A proton and an electron have same velocity. Which one has greater de Broglie wavelength? Proton था, electron the same velocity होते. De Broglie wavelength in terms of velocity. देखा है. Lambda is equal to h upon mv. Lambda is equal to h upon mv. Now mv ने lambda lambda is inversely proportional to 1 by v. Inversely proportional to v. So inversely proportional to v v lambda whichever has more velocity will have less wavelength, and with more velocity it will have less wavelength. Okay, so which one has greater de Broglie wavelength? Velocity same method. A proton and an electron have same velocity. Velocity same we have another factor. Vd constant J, but there are factor new is mass factor. So mass factor the factor the this question same wavelength. Okay. Now lambda is inversely proportional to mass. Okay. Now the proton and electron, the 1 marks question, so you don't need to write the calculation steps. You just need to write whichever particle has more. The sentence की formula T and T. Okay, which one has greater de Broglie wavelength? The de Broglie wavelength is the mass देता proton the mass share, electron the mass share. Obviously proton the mass the mass की 10,000 times electron की mass है. So mass proton की mass तो inversely electron की wavelength mass है because inversely proportional है. Okay, so answer first है electron. Answer is electron की wavelength the greater wave. Okay, formula देने से now the last question of 1 marks. How does one explain the emission of electrons from the photosensitive surfaces with the help of Einstein's photoelectric equation? CBSE 2017 question. So Einstein's equation, that is E minus phi naught is equal to kinetic energy max, or you can write h nu minus phi naught is equal to kinetic energy max, or you can write it as h bracket nu minus nu naught is equal to kinetic energy max. 하나 오늘 뭐야? found that is h nu minus nu naught is equal to kinetic energy max. Kadina khalalo emission dikhode explain chigide. So emission explain chale the equation in my t-shirt and my height here. If the frequency of incident radiation is less than, okay, now when I need to when nu is less than nu naught, kinetic energy max comes out to be negative, which is not possible. Okay, kinetic energy negative kinetic energy is always positive. So you see nu the nu ani change minus na so kinetic energy the nu which is not possible. So in order to see photoelectric effect or show photoelectric effect, nu should be greater than nu naught. Okay, incident frequency should be more than threshold frequency. This is how you decide it for 1 marks. Don't write more than 2 lines. Okay, formula di chisha any statement in one sentence. Okay, so next questions on your screen. Okay, so now we have a wonderful question here. Okay, so now we will do MCQs. This question was asked in NEET 2018. Let's see what it says. So in this question, when the light of the frequency 2 nu naught, okay, 2 nu naught, when nu naught is the threshold frequency, is incident on the metal plate, the maximum velocity of electrons emitted is v1. Okay, when the frequency of incident radiation is increased to 5 nu naught, the maximum velocity of electrons emitted from the same plate is v2. The ratio of v1 and v2. So we have to find v1 upon v2. Okay, we have to find v1 upon v2 is equal to question mark. That the question I will write the solution. I will write the solution here. Okay. So first of all, just try to solve this question by yourself. It's not an easy question, but not that hard as well. It's an average question, so try to solve it by yourself. Okay? I'll give you 2 seconds. Just pause the video and solve it. So I think you all have done it. So let's do the question. When the light of frequency 2 nu naught is incident on a metal plate, the maximum velocity of electron is emitted. So who much of formula this like the photoelectric effect equation formula you have to learn only one formula, or you can say the most important formula, that is Einstein's photoelectric equation. Because we are relating velocity with frequency. So Einstein's photoelectric equation kinetic energy max is equal to h nu minus nu naught. That is Einstein's photoelectric equation. Okay, kinetic energy max is equal to h nu minus nu naught. Is incident on the metal plate, the maximum velocity of electrons. So now case 1 when the light of frequency 2 nu naught is incident on the metal plate, frequency the 2 nu naught or kinetic energy. So kinetic energy max the velocity terms are 2. So half mv square the terms okay, kinetic energy is equal to half mv square max is equal to h. Incident frequency light of frequency is 2 nu naught and nu not the language. This is the first case. So this is your first case. Now second case. Second case now. This is your equation number 1. The second case now. When the frequency, first case now V1, when the frequency of incident radiation is increased to 5 nu naught. So second case now half m V2 square max D equal to h 5 nu naught minus nu naught. Okay, see, incident frequency D nu naught में माप करना मतलब ये जान बात है तो ये चीज़ radiation जो होगी ना electron मात्र दाने okay. Okay, so when incident frequency is 5 nu naught, V2 chale 2 nu naught ready, V1 there. Equation is as well. So very simple. Now we have to find the ratio. So dividing. Now dividing equation 1 by 2 on the other. You need to divide down the comma cancel. You will get V1 upon V2D whole square. Hello. And this side la this side la h gets cancelled. So now I do 2 nu naught minus nu naught upon 5 nu naught minus nu naught. Here I go. 2 nu naught minus 5 nu naught upon 5 nu naught minus nu naught. V1 upon V2D whole square is equal to 2 nu naught minus nu naught is equal to 1. 5 nu naught minus nu naught is equal to 4. Now d nikala root है तो root square d square this side so square था so therefore v1 upon v2 is equal to under root 1 by 4. Therefore v1 upon v2 is equal to 1 by 2. Answer is 1 by 2. Okay. Let's see 1 by 2 here. V1 upon V2 is equal to 1 by 2. 4 by 1 2 by 1 1 by 2. Option C is correct. Okay. 1 by 2 option C is correct. So now this is the second equation. Okay. Okay. Now a photoelectric surface is illuminated successively by monochromatic light of wavelength lambda and this one. So this is solved second question. This question was asked in All India Pre-Medical Test 2015. Tata photoelectric surface is successfully illuminated by monochromatic light of wavelength lambda and lambda 2. If the maximum kinetic energy of emitted photoelectrons in the second case is 3 times that of first case, find the work function. So this case now Einstein's photoelectric equation we should have. Okay. So the solution is originally. Okay. See here. Then case 1 is Case 1 now, photoelectric surface is illuminated by wavelength lambda. So Einstein's photoelectric equation in terms of lambda current, that is kinetic energy mass, is equal to at C bracket 1 upon lambda minus 1 upon lambda naught, where lambda naught is your threshold wavelength. Okay, so this is your Einstein's photoelectric equation in terms of wavelength lambda. Now first case now lambda if the maximum kinetic energy of the emitted photoelectrons, the second case is 3 times that of this kinetic energy. The work function is 1. Okay. Now first case now lambda into kinetic energy okay, A okay, A. Now case new now. Case new now kinetic energy D 3 times time. Question now 3 times time. Okay, you just have to convert the sentence, or you can say the written words into equation. Okay, equation 3 times kinetic energy max than the first case at C when the lambda is half into half na wala lambda by 2 so gana 2 le do it so gana 2 le do it is 2 by lambda minus 1 upon lambda now equation number 1 equation number 2 question sub 1 by lambda by 2 दी 2 by lambda दी 2 याद है बोला so तो क्या कर सकते हैं वर्क फंक्शन से ना okay so work functions in the dua so the layout first you have to find lambda from this equation okay you will find the lambda naught from this equation now lambda naught din is here lambda naught से same so phi naught की value 2 phi naught दिखा है hc by lambda naught okay phi naught दिखा है बोले hc by lambda naught से बोले so lambda naught din से घने से के divide dividing equation number 1 by 2 equation number 1 be divide से equation number 2 divide से ना जला balance 1 by 3 kinetic energy cancel and this side of the hc cancel gana khale do 1 upon lambda minus 1 upon lambda naught upon 2 by lambda minus 1 by lambda naught. This is your equation. So this solves na 1 by 3 is equal to so this solves we have lambda naught minus lambda upon lambda naught LCM नहीं and the wall LCM लेना ये wall LCM लेना अच्छा बोले 2 lambda naught minus lambda upon lambda naught lambda naught cancel lambda naught cancel then क्या रखा है 1 by 3 okay now 1 by 3 versus 1 by 3 1 by 3 is equal to lambda naught minus lambda inverse nasha so it's lambda naught minus lambda upon 2 lambda naught minus lambda that's all तो क्या फाइल से है lambda naught से है so lambda naught से ना क्या फाइल चाहिए ना 1 by 3 चाहिए ये क्या एनएच में दिख रहा है lambda naught upon 2 times lambda naught 2 times lambda naught minus this okay Yamna this squad. I think we are doing the longer version of this question. Yamna edit chishate. Nada mai gachi lambda se lambda ni define what se kachi chidis wa. Yamna kya trick tigla sha wo di jot se tu. Yamna kya edit chisha instead of writing this in terms of lambda naught namgu diran chite. Kachi na yada जबकि h nu minus phi naught here. And then I have h nu minus phi naught t. Inaya d case nala d case nala hc by lambda le d case nala hc by lambda by 2 le minus phi naught to use it. Find out midterm substitution. You can find out equation number 1, equation number 2. So कैसे d ni divide करना किसी d ni divide करना and क्या होता है 1 by 3 is equal to hc by lambda minus phi naught upon 2 दिया था 2hc upon lambda minus phi naught this is so the d equate d क्या गी LCM लेना कैसे दूँ hc minus lambda naught lambda phi naught upon lambda upon 2 hc minus lambda phi naught upon lambda cancel and d can position 파타샤 파타나 캬나 가다 보래 2hc minus lambda phi naught is equal to 3 times hc minus 3 lambda phi naught. Ini dah expansion. Okay. Tadi sama di sana B equation di. B equation di definition. Cara pada 2h minus lambda phi naught. Sorry. What is it? 2hc, yes. So 2hc minus lambda phi naught the definition is equal to 3hc minus 3 lambda naught lambda phi naught. Ini begini. तो यहाँ phi naught से है 3 lambda phi naught से क्या? तो 3 lambda phi naught minus lambda phi naught is equal to 3hc minus 2hc. That लेना सकता है लोग ऐसा. That 3 lambda naught minus lambda phi naught है ना बस 2 lambda phi naught. Last 3hc minus 2hc क्या है? hc. Okay, hc that's all. So therefore यहाँ phi क्या है? Phi naught. That is your work function. Work function is hc by 2 lambda. Now hc by 2 lambda is the answer. hc by 2 lambda. Option B is correct. Okay, answer दिखा रहे option B. Option B is your answer. चलो देख लेते हैं कि ये lambda not determined है question answer. देखिए थोड़े तो ये equation बोलने को चाहिए तो क्या हमेशा solve it in terms of find out directly क्या फायदा होगा. Okay, यहाँ के नंबर h new t new this सब lambda ठेले. First case ना lambda दे and second case ना lambda दे lambda by 2 दे. That is given in the question. Okay, so you will get hc by 2 lambda. Okay, now we will cover the next questions, or you can say the remaining questions in the upcoming video. Hope you are studying well. Okay, keep studying hard. Do not want to disturb you all for doing so much questions right now. Okay, I will do the questions later on. Okay, so keep studying hard and don't forget to like, share and subscribe my channel. Okay, good day.